So the big problem in statistical mechanics is how do we count states? Counting microstates. So in order to make our lives a little bit more easier or simpler, we have decided that we are going to divide these things into two main categories. One is when we can distinguish particles. And one's when we cannot. Bless you. Okay. And when we talk about distinguishable particles, these are further divided into three categories. Case 1, case 2, and case 3. Case 1 is when we have a limit of one particle per container. I can find my multiplicity if I have m containers and n is my number of particles. I can write my multiplicity as m factorial divided by m minus n factorial. Call this 1 for case 1. Case 2 is I have n distinguishable particles, and each container M can hold exactly n number of particles. Then my multiplicity will be given as n factorial divided by the running total over ni factorial. Case 3 is when there is no limit on the number of particles per container. In this case, my multiplicity will be given by m to the power n, and this is called Boltzmann statistics. I would put this in a box, and I would change the color of this to red. That's important. Yes?
For the multiplicity for number 1, n minus n factorial or
No.
n minus n parentheses factorial?
Excellent point.
Okay.
M minus n bracket factorial. Thank you for pointing that out. Okay, now what about indistinguishable particles? There are two different scenarios. One is m containers, n number of particles with a limit of one particle per container. that multiplicity will be given as m factorial divided by n factorial, m minus n factorial. Does that remind you of something? Have we seen this before? Last chapter.
Combination.
Mm-hmm.
Yeah. There we go.
And permutations and stuff. Yeah, that's exactly the same.
This one.
And that, in fact, is called the Fermi-Dirac statistics. And the particles that follow this Fermi-Dirac statistics are called fermions. Okay, pick a color for this, guys.
Purple.
No, pick something fun. Teal.
Cyan.
That's the same.
Last one. N containers, M containers, N particles, no limit on the number of particles. Multiplicity given as gamma 5 equals n plus m minus 1 factorial divided by n factorial m minus 1 factorial. This is the basis for Bose-Einstein statistics. And the particles that follow the Bose-Einstein statistics are called bosons. Bosons are spin 1 and spin 0 particles. For example, photons. You know, light. Whereas fermions are spin half particles. For example, helium atoms, lithium, nuclei. And these are 3 half, spin 3 half. This is spin half particles. So the next time you hear the word fermions and bosons, know that it's not complicated.